Today's notes are on performing function operations and composition. Operations on functions says let f and g be any two functions. A new function h can be defined by performing any of the four basic operations: addition, subtraction, multiplication, and division on f and g. So for the operation addition, h of x is equal to f of x plus g of x. So for example, if f of x was equal to 2x and g of x was equal to x plus 1, we would take the f of x value plus the g of x value and combine like terms to get 3x plus 1. Same thing for subtraction. We would take f of x minus g of x. You do want to be careful here though, because that negative would be distributed to both terms of g of x, so you'd really get minus x minus 1, which simplifies to x minus 1. F of x times g of x tells you to multiply. This time, because I have a monomial times a binomial, we have to again distribute 2x to both x and 1 to simplify. And then we have division. And for division, it's not always possible for us to simplify. Just like this example, because this x in the denominator has the plus 1 attached to it, I can't cross off the x that appears in both the numerator and denominator, so my answer is just what you see below. The domain of h consists of the x values that are in the domain of both f and g. Additionally, the domain of a quotient does not include x values for which g of x is equal to 0. We are going to talk about the domains in more detail in class, so we're going to worry about just simplifying the functions for today. So the first one, example 1a, f of f plus g of x. So we're going to take the f value, which is 2x to the 1/2, and I'm going to add it to the g value, which was negative 6 times x to the 1/2. Because they both have an x to the power of 1/2, we can combine them together. So 2 plus a negative 6 gives me negative 4. So I get negative 4 times x to the 1/2. Again, we're going to talk about the domain tomorrow, so we're just going to skip that for right now. We're going to look at example B. It's going to be set up very similar. Our f value minus the g value, so this time we're subtracting a negative number, which means that really turns into a plus, so our answer is 8x to the 1/2. We're also going to look at simplifying example number 2, the multiplying and dividing. So f times g, so I would have 4x to the 1/3 times my g value, which is x to the 1/2. And using our properties of exponents, it tells us because we have the same base of x, that we're going to add the exponents together, which gives us 4x raised to the power of 5/6. And we're going to talk about the domain in class. So the last one that we're going to look at today is example 2b, and that's f over g. So once again, I'm using the properties of exponents, which tells me if I have the same base of x in both the numerator and the denominator, that I can take the base and I can take the exponent in the numerator and subtract it by that in the denominator, which leaves us with 4x to a power of -1/6. And then because we don't like negative exponents, we're going to drop just the x to the denominator to create a positive exponent. So 4 over x to the 1/6. And again, we're going to talk about the domains tomorrow in class. We're also going to talk about the composition of functions on the second page tomorrow. So you do not have to try anything else on your own. You can read through the box at the top of the next page.